Hello, my name is Krus, and this is my favorite way to describe what is an SD-WAN, software-defined wide area network. Okay, because imagine that you have a bunch of physical locations. So here is your main data center. Maybe you have a secondary data center. Maybe you have a small office somewhere. Maybe you have a factory, another office. So you have a bunch of physical locations. They have the need to communicate with each other. In the uplink direction, there are a bunch of different alternatives. So depending on where in the world you are, you connect your sites in the uplink direction using MPLS, internet connection from some other provider, 4G, 5G, or whatever is the ability that you have per physical location. So in the middle here, we have connection, different ways to connect to each other. MPLS we said, internet from another provider we said, 4G maybe, 5G, and whatever you have here. In an SD-WAN kind of approach, then we look at the available bandwidth here as a just a way to communicate. So you can look at it like this. Let's just draw a circle. So these are the physical locations that you manage. We call it the LAN side. These are uplinks technologies that you buy or acquire from someone. Let's call this the WAN side, the WAN side. In the Velocloud solution, you put something to each individual physical location, and we call it an edge. An edge is a software thing that might run in a virtualized hypervisor, or it might run on an appliance. It doesn't matter. It's the function of the edge software that we are looking for. So in my picture, the edge is over here. And again, for the sake of the argument, it doesn't matter if this is a VM or if it's just a software that runs somewhere on a hypervisor. Because from an uplink point of view, each physical location and the edge is connected in uplink to one of these uplinks or maybe multiple. A little bit depending on, of course. So maybe it's looking like this. Okay. So first of all, if you have an SD-WAN software, and this is managed by the orchestrator. So in my picture here, there is an orchestrator somewhere. So this is me using the orchestrator, and I just orchestrate everything, all my edges. So these are my edges. Edge. Can put a little cable here, like this. Okay. First of all, what topology can I use? Well, you can use basically any topology. This is software, so you can create a full mesh, you can create a partial mesh, you can create a hub and spoke, you can do it multiple times in multiple layers. It doesn't matter. This is software. More or less, you can create any topology of your choice. But an SD-WAN is much more than just a managed IPsec thing. In an SD-WAN, there's a lot of intelligence. So first of all, when you connect an edge to uplinks, what the edge will do then is quality measure. So every edge will quality measure every uplink. So we will of course check the bandwidth, we will check the latency, we will check the jitter, we will look at bit errors, and we will look at faulty frames, and we know the quality of all the uplinks. So once now, when we start to use our SD-WAN, we know exactly what is the quality of the uplinks available on all of our edges here. So now I have applications here. So imagine that I have an application here talking to an application over there, or someone over here talking to someone over there. It doesn't matter. What we will do then from an edge perspective is that we will use something that we refer to as deep application recognition. So we will look at the behavior of the traffic, we will look at the destination IP range, we will look at the layer 4 protocol, we will look at information within the certificate. We will try to identify, and there are hundreds and hundreds of different applications that we can identify from a quality perspective. So depending on if this is a real-time service, is it a voice stream, is it a transactional service, does it mean a lot of bandwidth, what is the profile prioritizing different applications on my edge, then I will use either maybe this link or both links, depending on if I need bandwidth or if I prioritize low latency or whatever. And if something changes, then I might do per packet link steering, because we will quality measure continuously all the uplinks. So if the uplink is silent, then we will probe it every now and then just to make sure what is the quality at this very moment. If we have traffic on an uplink, then we will piggyback with the quality report. So we know the quality of all the uplinks on all the edges at every instance in time. So now I have the ability to communicate in east-west direction, and if this is a transactional service that needs a lot of bandwidth, then I can aggregate. So if I have two 1 gig uplinks, then actually one single transaction application can use 2 gigs of data, more or less. If this is something that moves, maybe this edge is within, I don't know, within an ambulance or in a submarine or within a car, self-driving car, or whatever is our use case, an unstable network, then I can do a per link packet steering if this is desired, depending on how I created my profile in the orchestrator. Okay, so right now on the board, I have taken care of what we refer to as the east-west traffic. So traffic between entities that I manage. So this is my infrastructure, and I consume the bandwidth. From a logical point of view, this is my SD-WAN taking care of any communication. And within the SD-WAN, if I have bit errors, I will retransmit. I can do jitter buffing. I can do forward error correction. I can do a lot of things, making this overlay look better than the actual underlink is, because I do the forward error correction, I do the link steering, I do the aggregation of, and I do the retransmission, or whatever I do depending on the settings in my profile. But the north-south traffic use case is also something that we need to take care of, meaning that imagine that I have a user here, and this user is consuming something out on internet. So maybe we are using Office 365 or something. So there's an internet service somewhere out on internet. That means that this application needs to do a breakout out from the SD-WAN. I am not communicating between stuff within my management. I'm talking from inside to outside, from WAN to LAN to WAN, I should say. Then I must do a breakout. And there are a couple of different ways that you can do breakout. So imagine that this is an application and we go towards the edge. The edge uses deep application recognition. Then we can say that, okay, according to the settings, this application should do a local breakout. So directly on the edge, on the local edge, we do a breakout, and basically we go outside of the SD-WAN towards the whatever that we are consuming out on internet, for instance. The downside of local breakout is that if you do local breakout, you are vulnerable from attacks in the reverse direction. So you may be attacked. That means that you should have, from a security point of view, you should have firewall capabilities. So if you have a bunch of sites, you need to have equally many firewalls per site. Otherwise you are vulnerable if you allow local breakout. The alternative to local breakout is to do backhauling, centralized breakout. So let's say that this is your primary data center. In your primary data center, there's a really fancy firewall from some vendor. Then, of course, what you then may do is that from your application, you go to the edge. The edge recognize this application as something that should do a backhaul breakout. So we are using the SD-WAN to get to the data center. We reach the firewall. The firewall is doing something, some kind of firewalling, And then the firewall is the entity that lets this traffic out on internet, so backhauling or centralized breakout. The downside of centralized breakout is that you get hairpinning, and you get a choke point where your firewall, your main firewall, needs to firewall a lot of stuff. So you bring a lot of traffic from around your network into a centralized data center, and you need to cope with it there. So the third option, that is kind of SD-WAN specific, is that you do distributed breakout. Because there is one more node here, or a node infrastructure, that we refer to as gateways. So VMware has placed a lot of gateways out on internet. So let's symbolically, I just put some dots here, and the dots represent the hundreds and hundreds of gateways that are out on basically every major data center all over the globe. So what you may do, if you want to, is that you identify your application, you take the SD-WAN as far as you can, and then you do a breakout on the gateway infrastructure that is not managed by you but consumed by you, and from there you do a breakout as close to the destination as possible. This means that you have used all the good things from the SD-WAN, and by the good things I mean the link steering, the quality retransmission, forward error correction, and all of that. So we are using all of this, and this may be combined with a distributed firewall service, and there are a number of different companies that does this, meaning that when you break out, even though you break out from a gateway not managed by you but only consumed by you, you can have a corresponding distributed firewall service that takes your traffic and firewalls it before it goes out on internet. That means that you use the SD-WAN, you use all the good things with the SD-WAN, you break out as close to the destination as possible per identified application, and thereby you avoid hairpinning, and you still get the firewalling, but it's performed by the distributed firewall. Okay. So this is just one way to describe an SD-WAN. The infrastructure is managed by you on the outside. The available uplinks, those are just raw bandwidth, something for you to consume. With an SD-WAN, we can consume it as intelligent as possible.